Today, we are going to be looking at how certain basic mathematical principles can be applied in chemistry, in solving chemistry problems. Do you know that you can only be a good chemist if at least you understand some basic mathematical principles? Do you also know that chemistry has much to do with mathematics? So I'm going to take us through one or two basic mathematical principles and how we can relate them to solving chemistry problems. Today, we will look at how we can probably relate fractions in chemistry. So, we'll look at fraction in chemistry. Fraction in chemistry. Now, mathematically, you have so many fractions and so many ways to solve these fractions. But do you know that there are also chemistry questions that will be asked and it's expected of you to use the relative understanding of the fraction in solving mathematics to solve them? Let's take a mathematical fraction question and see how we can solve that first before we relate it to chemistry. Supposing you are given, let's say, this is maths. This is maths. Supposing you are given 2x plus 6xy all over 4x squared plus 10x cubed. And you are asked to solve this. This is a fraction. Fraction can come in any way. But what you must understand is that fractions have both what? Numerator and denominator. There must be a numerator, there must be a denominator. How do we solve this fraction in mathematics? Now, understand the fact that there is a 2. A fact for this particular numerator, we have common factors, which is 2. So 6 can go into 2 without a remainder, and 2 can go into 2 without a remainder. So 2 is a common factor for both. So we're going to bring 2 out and put the x. So 6 divided by 2, which is a common factor, 2 is its common factor, will give us 3xy. All over what? The same thing happens here. 2 is also a common factor for both. So if we bring 2 out, we have what? 2x squared plus 5x cubed. That means we have 2 times 2 will give us 4, 2 times 5 will give us 10, 2 times x will give us 2x, 2 times 3 will give us 6. But we still have a common factor even inside here. And that common factor is x. So we can do with x too. So we can put x is here and x is here, x is here and x is here. So we can pull it out. So we have here as 2x to 1 because there's no more x here, plus what? Plus 3y. And then we have all over what? 2x. Because there is only one x here remaining, we have what? We have 2x plus what? 5x squared. This is because already you're pulling away x from here. So 2x is remaining. And then you are pulling away x from here. So only x squared is remaining. 5x squared is remaining. So from here, this can cancel this. And then what we now have is 1 plus 3y all over what? 2x plus 5x squared. This is the answer to a mathematical fraction solved in this way. But how do we apply the chemistry part of it? How do we apply the chemistry approach? I'm using fraction in mathematics to solve chemistry problem. You can be asked a question. For example, what is the fraction? What is the fraction of hydrogen? Or the fraction of water? Let's say the fraction of the mass of water in hydrogen. That is to say, what is actually hydrogen amount in water in terms of mass? Okay, that is chemistry for you. What is a fraction of the mass of water in hydrogen? So you can look at it in that way. And now we say, okay, if that is the case, that means we are trying to say, what is hydrogen, the amount of hydrogen in water in a fractional way, in a fractional form. Let us look at this. Water is H2O. And I'm sure we know that with H2O, hydrogen has an atomic number of 1. Is it not so? So here we have hydrogen 2, which is this, times 1. And then we have oxygen, or rather we have oxygen. And we know that oxygen has an atomic number of what? 8. So the atomic mass is what? 16. So we have oxygen is 16. So it means that 2 plus 16 will give us what? 18. This is the atomic mass, or the molecular mass of water. But what is the amount of hydrogen in this molecular mass of water? What is the amount in a fractional form? That is what we are saying. Let's now back to what we have here. So it means that hydrogen is 2. Is it not so? And water is 18. Therefore, the fraction of hydrogen, okay, is going to be, in water, is going to be 2 all over 18. And this will be what? 1 all over 9. So this means that the fraction of hydrogen in the molecular mass of water is what? 1 over 9. So you can see that it is only the basic understanding of basic mathematics or mathematical techniques you will be able to solve some chemistry problems, if not all of them. I'm sure that today you had something to learn. You've been able to understand that fractions that you see in mathematics can also be applied in solving chemistry problems. Do not forget to share, do not forget to like, don't forget to subscribe, to follow, to comment. Until next class, it's bye for now.